Hello students, welcome back. Now let's go to section 5, continuity condition. I wrote many problems here because I think these problems are interesting and to a certain degree important, but I wasn't able to find many problems either from Pearson's MyMathLab or Cengige's Web of Science. So the only way is for me to write some problems like this, it appeared. So I wrote a lot. So doing all these problems will give you a lot of repetitions. Okay, let's go to the first problem here. Basically, we have two possible breaking values. X equals to what? And x equals to what? Well, we have these three intervals. So they're going to be separated by two x values. You see, two x values will divide the number line in three pieces. What are those x values? X equals to 1, and that's common in first and second line. And x equal to 3, that's common in second and third line. So plug in x equals to 1 here, we get the left-hand side limit. Plug in 1 to the second line, I'm going to get the right-hand side limit. 1 squared minus 2 times 1 is equal to 8 times 1 plus 1. And that's going to give you an equation. Now, another possible breaking point is x equal to 3. And x equal to 3 is common in second and third lines. So putting x equal to 3, 8 times 3 plus 1, negative 3 squared plus b. Okay, what do we have? We have two equations and then two unknown parameters, a and b. We can solve it. In fact, it's really easy to solve the first one because I have only one variable here. Yeah, I can solve for a, and then plug it into this, and that's going to give me b. Shall we go ahead and do that? Okay, let's see. Plug in x equal to 1, and then set these two equal to each other. I get a equal to negative 2. And then plug it in, and then from second and third, and then we have the second equation, we get b equals to 4. So a is negative 2 and b is positive 4, and at those two values we have to have a continuity. Make sense? Here's the solution again. X equals 1 is common in first and second line, so plug in first line, second line, set them equal to each other, and then x equals 3 is common in second and third lines. Plug it into second line and the third line, set them equal to each other. We have two equations and two unknown parameters, a and b. You can solve it. That was an easy one. A little bit more challenging will be this one. Setup is not challenging at all. The same, plugging x equals to negative 2 to the first line and second line. Is that clear? Negative 2 appears here and there, so second line, third line. And x equals 1 appears in third line and second line, so plug those in. So here, so first line equals to second line at x equal to negative 2. So plug negative 2 there, and then plug in negative 2 here. Okay, all right. That's for x equal to negative 2. And then we can set the second line and the third line equal to each other. At x equal to 1, that's common. So plug in x equal to 1, plug in x equal to 1, do the same thing here, plug in x equal to 1, plug in x equal to 1, and that gives me the second equation. So what do we have? We have a system of linear equations. Two equations and two unknown parameters, a and b. Simplify and solve those, you're going to get the answer. So, if you want to do this, stop the playback and do this. So, what do we have here? Did you get it done? Well, let's see. Here we go. Plug in the first line, plug in the second line, set them equal to each other, and I have equation number 1. So, same as this one, simplified. Plug in x equals 1 to the second line and the third line. They must be equal to each other so that we get simplified form, the second equation. That's the same as this one. And solving the system, well, let's see, that's blue, and that's green, and you can use, oh yeah, you can use elimination here. Subtract one from the other, we get a equals to 5, and then plug it in and do your computation for b. 7 halves. A is 5, b is 7 halves, and indeed, we have a continuity. Too long to fit everything into the same viewing window. Okay, we have a couple more. This time, would you like to set up and do completely? Okay, did you get it done? Stop the playback and get it done. Okay, all done? Well, plug in y equals to what and y equals to what? Y equals to -1 to first line and -1 to the second line. Set them equal to each other. Y equals +1 to second line, +1 to the third line. Set them equal to each other. That way we're going to get two equations. So first line and second line equal to each other. Simplify, simplify, we get the first equation. That's when x equals to -1. And then put y equals to 1. Set them equal, and then simplify, we get the second equation. Y equals to +1. So y equals to -1 here, blue. Y equals to +1 here, green. And with these two, we get a system of linear equations of a and b, respectively, blue and green. And then solve the system, again by elimination. Subtract, we get b equals to 0, and then plug it in, do your computation. A equals to -1. Here, how about this? Okay, I'll leave that to you. First line, t equals to -1. They have to be all the same, so we have the first equation. Plug in t equals to 2. They have to be all the same, so set them equal to each other. We get an equation, red. Solve the system. Looks like, again, the elimination can work. A equals to 2, b equals to -7/5, and yes. How about this one? This one looks a bit strange because we have only two lines. Two lines setting the first and second equal to each other at x equal to 3. And that's going to give me only one equation. But how in the world do I have two unknown parameters, a and b? Well, good luck. How to find the second equation? You have two variables here. So we need two equations. At x equal to 3, I'm going to get only one equation. But the answer lies here in this expression. If you plug in x equal to 3, in order to set up 1/2 3 squared plus a is equal to, plug in 3 squared minus b over 3 squared minus 2 times 3 minus 3. And don't just give up if you try to simplify a little bit, especially the right hand side, because left hand side is pretty much all set. Yeah, okay, let's simplify the right hand side. We get 9 minus b, and then the denominator, what do you get? If I plug in x equal to 3, 9 minus 6 minus 3, we get denominator 0. Doesn't make sense. It does not make sense. So how does it make it work? Well, number one, x equals to 3 is not here. It's up there. So as far as well-defined, no problem there. We only need a limit. In order to have a limit, this has to be a 0 over 0 type. Something else over 0 will never give me anything, you see? In order to have anything valid, we have to have 0 over 0 type limit. So this expression have to be like this. And then this one down here will become a limit computation. Limit computation of this so a limit computation 3 and then actually 3 plus, but it doesn't really make much difference here. Divided by x squared minus 2x minus 3. If you do this computation, and that value versus the first line, well, that's going to give you an equation. So instead of this, which is invalid, if you do this, things will make sense. So what's this limit? You can do this computation, and once you do that, you can find out a value. Good luck. Completed? Not yet? Well, here we go. If you do all those computations, and then set those right, in the end you're gonna get, well, limit value is 3/2, so a value -3, and that's gonna give you a continuous function. That completes the problem.